is the chemistry gang.
So today we're going to be talking about a big component in rates of reactions, catalysts. We are going to demonstrate this through an experiment called Elephant Toothpaste.
Elephant's toothpaste is described as a very exothermic reaction, meaning that it produces heat as the reactants turn into products. It also demonstrates how a catalyst works in a reaction and how it impacts the rate at which they react. For this reaction, we are going to need 110 milliliters of hydrogen peroxide, 1 packet of dry yeast, 15 milliliters of warm water, liquid dish soap, a flask, and of course, safety goggles and gloves.
Measure out approximately 110 milliliters of hydrogen peroxide and pour it into flask carefully. Add dish soap to the flask and swirl until the contents are completely mixed. In a separate container, combine 15 milliliters of warm hot water and 1 packet of dry yeast and mix for about 30 seconds. Pour the yeast into the flask, and we have a reaction.
So how does Elephant's toothpaste relate to catalysts? In order to begin our discussion about catalysts and how they work in a reaction, we must first understand the activation energy, or EA. The activation energy of a reaction is the energy difference that the reactants must overcome in order to react and become products. Reactions with high activation energies sometimes need a boost to get over the energy difference to form products.
This is where the catalysts come in. A catalyst is present in solution, so it can provide a different pathway for the chemical reaction to take with a lower activation energy without participating in the reaction. In other words, a catalyst lowers the activation energy and doesn't affect what's going on in the reaction other than the rate.
Thinking about what we did in Elephant Toothpaste, if we were to just let hydrogen peroxide sit in the air, it would decompose into water vapor and oxygen, but not very quickly. Therefore, in more scientific terms, not much oxygen is produced from the normal decomposition reactions, since the bubbles are filled with oxygen gas.
However, once we add yeast to warm water and then add that to the hydrogen peroxide and soap solution, we can see that many oxygen-filled bubbles are produced. So the yeast acts as a catalyst. Therefore, as shown by Elephant's toothpaste, the presence of a catalyst will speed up the rate of the reaction.
Yeah, because otherwise you always like have to